Now student, we are going to discuss next question, and this question is a question number 7.17, and in this question it is given to you a meter stick is balanced on a knife edge at its center. Clear? So let's suppose I am drawing here. Let's suppose I am drawing here a meter stick. Let's suppose this is a meter stick and it is balanced with at the knife edge like this. Clear? And at its center, so we can say, because this is a meter stick, it means I can say position of center of mass that is given by 50 centimeter. This is given in a question. Clear? Now when two coins each of mass 5 gram. Clear? So now we have a second situation. In second situation it is given to you when two coins each of mass 5 gram are put one on top of the other at 12 centimeter mark. So let's suppose I am having here one coin and let's suppose I am having here another coin. Clear? So we have here two coins and having mass 5 gram and 5 gram. Clear? And position of these two coins is given to you 12 centimeter. Clear? Now it is given in a question, we are finding the stick is found to be balanced at 45 centimeter. Clear? So now let's suppose this knife edge we placed here at the position of 45 centimeter. Clear? Now what is our objective in this question? Our objective is here, what is mass of a meter stick. Clear? So now we can calculate here mass of meter stick like this. First of all, if we find here total number of forces acting on this meter stick, I can say here definitely 1 mg that is acting here, that is the self weight of this meter stick. Clear? From here we can say here a normal reaction is also acting here, normal reaction. Clear? Definitely here we have two coins, it means I can say 10 g force is also acting in a downward direction. Clear? So now we can say when this system is in balancing position. Clear? I can say definitely horizontal, vertical, and we can say torque, all are balanced, and torque is balanced at about any point. Clear? So we can say here, if we are taking here torque with respect to point, or with respect to, I can say point, let's suppose I am taking this as O, so with respect to point O. Clear? So now I am talking about torque with respect to point O. So how can we write here value of torque? Now let's just try to understand. Definitely if I am talking about this mg, this torque due to this mg is in a clockwise direction, so I can say mg. But here we will write perpendicular distance. So now we can say this distance is given to you, that is 50 centimeter. Clear? This distance we have 50 centimeter. Clear to everyone? And we have this distance 45 centimeter. It means we can say here, we can write this is 50 minus 45 centimeter. Always keep in mind here, I am taking this length in a centimeter, I am taking mass in a gram, it means I am dealing in a CGS units. Clear? Now I can also say here, if I am talking about torque, that is due to this 10 g, I can say 10 g multiply. Now what is distance between this normal reaction and this force? I can say we have total 12 centimeter, this one total, this is 45 centimeter. It means I can write like this, 45 minus 12. Clear? So now I can write like this, value g and g, this one is cancelled out. Clear? And m multiplied with 5, this should be equal to 10, and we can say this is 33. Clear? So now we can say value of m, this is given by 10 multiply 3 divide by 5, and we can say this is 66 gram. Clear? So what is mass? What is mass of this meter stick? Mass of this meter stick is given by 66 gram. Clear? So this is all about this question. Now student, we are going to discuss question number 7.18, and in this question it is given to you, we have a solid sphere rolls down two different inclined planes of the same height. Clear? So let's suppose I am drawing here two inclined plane. Let's suppose this is one of the inclined plane. Clear? And I am saying this value we have, this angle of inclination we have theta 1. Clear? Now let's suppose I have one more inclined plane like this. Clear? And I am saying this is like this. Clear? And let's suppose this angle of inclination is given to you theta 2. Clear? I am assuming here theta 1 is greater than theta 2. Clear? it is also given here we have a solid sphere. So let's suppose here we have a solid sphere and we also have same solid sphere here. Clear everyone? So we have here two solid sphere and actually they are moving to the bottom. Clear? Now first part is here, will it reach the bottom with same speed? So actually I think you know this, when this solid sphere will move in a downward direction, actually it will translate as well as it will rotate also. Clear? So we know one formula. That formula we have, speed is given by under root of 2gh upon 1 plus k square upon r square. Clear to everyone? Yes or no? So speed of a solid sphere at the bottom, this is given by under root of 2gh upon 1 plus k square upon r square. Clear? So now if we talk about both the cases, we can say h. H is what? It is already given in a question. We have same height. So I am saying this is h and this is also h. Clear? So when we are having same height, clear, and because we have solid sphere, so radius of gyration is also same. Clear? Or we can say radius, that is also given to you because we are taking a solid sphere only. Clear? It means we can say v is same in both the situation. Clear? So we will find both solid sphere will reach at the bottom with same speed. Clear? Now if we talk about part number B, in part number B it is given which one will take a longer time. So if I talk about acceleration, acceleration is given by g sin theta divided by 1 plus k square upon r square. Clear? So from here you can say yes, definitely k is same for both the situation, but directly we can say acceleration is directly proportional to sin theta. Clear? So it means we can say if we talk about these two inclined plane, theta 1 is greater than theta 2, it means I can say acceleration will be more in first case compared to second case. Clear? So when acceleration will be more, I can directly say definitely time taken in case 1 is less compared to second. Clear? Or we can say here the inclination, the inclined plane that is having a small inclination, the inclined plane that is having small inclination, we can say it on that inclined plane that this solid sphere takes a longer time to reach at bottom. Clear? So this is all about part number B. Clear? And we have already solved here, if so which one is and why. Clear to everyone? Because it depends on angle of inclination. Clear? So my dear student, this is all about this question. Now student, we are going to discuss question number 7.19, and in this question it is given to you a hoop of radius 2 meter. Clear? So radius is given to you, that is 2 meter, having weight, that is mass is given, mass is that is 100 kilogram. Okay, it rolls along a horizontal floor so that its center of mass has a speed 20 centimeter per second. So I can write like this, this is 20 centimeter per second, or I can say 20 into 10 to the power minus 2 meter per second. This is given to you in a question. Clear? How much work has to be done on it to stop it? Now listen carefully. Actually this is a we can say this is a hoop of radius. It means whenever it is actually moving on a horizontal surface, we can say actually there is a translation as well as the rotational motion is taking place. Clear? So the total amount of work that is required if we want to stop this hoop, so at the time we can see net work done that we have to do, this is equal to kinetic energy. Clear? So whatever kinetic energy it have, first of all we have to provide that much amount of work and we have to do that much amount of work on it. Clear? So that we can say that net work done, it should be whatever the work done we are doing, it should be equal to kinetic energy of this object. Clear? So kinetic energy is actually associated with, we can say translational kinetic energy and rotational kinetic energy. Translational we can see half of m v center of mass whole square plus half of I. Clear? Half of I omega square. Clear? So I can say 1 by 2 capital M v center of mass whole square. V center of mass whole square means directly I am writing like this, v center of mass. Clear? 1 by 2. Now if I am talking about it is having some radius, so we can say moment of inertia is given by mr square, and what about omega? We can say this is v center of mass by r whole square. Clear? So from here we can say work done. This work done, this is given by 1 by 2 m v center of mass whole square plus I can say 1 by 2 m r square v center of mass whole square, this is r square. Clear? From here I can say r square and r square, this is cancelled out. So net work done, this is equal to v center of mass whole square. Clear? Now mass is given to you in a question, that is 100 kilogram, and what about v center of mass? 20 into 20 into 10 to the power minus 4. Clear everyone? So now we can say this is 400. So 400 into 100 into 10 to the power minus 4. 1, 2. So we can say here we have to provide here 4 joule of work. Clear? So now we can say total amount of work that is required if we want to stop this hoop, that is equal to 4 of joule. Clear? So this is all about this question. Clear? We are going to discuss question number 7.20, and in this question it is given to you the oxygen molecule has a mass of 5.30 into 10 to the power minus 26 kilogram, and a moment of inertia is also given to you. So now you can see value that is given mass is given 5.30 into 10 to the power minus 26 kilogram. Clear? And moment of inertia that is given to you 1.94 into 10 to the power minus 46 kilogram meter square. Clear? Now it is given that suppose the mean speed of such a molecule, means I can say mean speed means you can also say v. Let's suppose this is v, and that is given here 500 meter per second. And the most important part in this question given, kinetic energy of rotation is 2/3 of kinetic energy of translation. Clear? It means it is given here kinetic energy rotational, kinetic energy of rotation that is equal to 2/3 of kinetic energy of translation. Clear? So kinetic energy of rotation, this is equal to 2/3 of kinetic energy of translation. Clear? So now we can say kinetic energy of rotation is given by half of I omega square, this is equal to 2/3 I can say half of we can say mv square. Clear everyone? So now we can say half and half, this one cancelled out. Now what is our objective in this question? Our objective here is to calculate average angular velocity. Clear? So from here we can say I square, this can be written like this, 2m divided by 3i, and I can say this is v square. Clear? 2m divided by 3i and v square. So value of omega is given, this is v under root of 2m divided by 3i. Clear? Now we can put here all values and we can easily get our answer. Clear? Yes. So now we can put here all values. So omega, value of v have, that is 500. Clear? Under root of, I can say 2 multiply mass 5.30 into 10 to the power minus 26. Clear? And divided by, I can say 3 multiply, now I can say I we can say moment of inertia 1.94 into 10 to the power minus 46. Clear? This is given to you. So if you solve it, you will find values, that is approximately we can say under root of 1.82 into 10 to the power minus 20. Clear? If you solve it, definitely you will find this value. So from here we can say, we can write like this, 500, this is 1.82. So we can say what is the square root of 1.82? 1.82 square root we will find near about, you can say like 121 we have 11. Clear? 144 12, 169 13, 196, that is we can say 14. Clear? So near about 1.3, so I can say 1.36 into 10 to the power minus 10, and we can say this is radian per second. Clear? Now we can also write like this, 5 into 136 into 10 to the power minus 10. So if you multiply, you can easily get your answer. We can say this is 30, we have 3, so 15 we have 18, and Yes, and we can see here this is 680. So 680 into 10 to the power minus 10, and we can say this is radian per second. Clear? So we can say this is average angular velocity of this oxygen molecule. Clear? So this is all about this question. Now student, we are going to discuss question number 7.21, and in this question it is given to you a solid cylinder rolls up an inclined plane of angle of inclination 30 degree. Clear? So let's suppose I am drawing here, just a minute. Yes, let's suppose I am drawing here an inclined plane. Clear? Let's suppose this is an inclined plane. Clear? And let's suppose this is making an angle theta like this. Clear? Here we have a solid cylinder. So I can see here we have a solid cylinder. This is important. Here it is given solid cylinder. Okay. It rolls up an inclined plane of inclination 30 degree. Okay. At the bottom of inclined plane, center of mass having speed. So we can say V center of mass. This is given to you 5 meter per second. Okay, fine. How far will the cylinder go up the plane? Clear? How far will the cylinder go up the plane? Clear? So first of all, if I am talking about kinetic energy of this cylinder, so we can say because this cylinder is going on an inclined plane from bottom to top, definitely it is having translational as well as the rotational kinetic energy. Yes or no? So I can say here kinetic energy, this is given by, we can say half of m v center of mass whole square plus half of I omega square. Clear? So actually what is our objective in this question? Our objective is very clear, that cylinder, how far will the cylinder go up the plane? Second, how long will it take to return to the bottom? Clear? So now we can say, we can write like this, 1 by 2 into half of m VCM square plus half of, so we can say Vm VCM square plus 1 by 2 I. We can say moment of inertia. Moment of inertia, we can say here we have, that is Mr. We can say because this is solid cylinder, for solid cylinder we can say this is Mr square by 2. Clear? And omega we can write like this, VCM divided by R whole square. Clear to everyone? So from here we can write like this, value of kinetic energy, this is given by half m v center of mass whole square plus 1 by 4 mr square multiply v center of mass square and r square. We can say this one and this one cancelled out. Clear? So from here we can say total kinetic energy is given by 3 by 4th mvcm square. Clear? So this is value of kinetic energy. Clear? Now let us try to understand first concept. Concept is very clear. Let's suppose I am taking here, this is my reference. Clear? So if I write here initial position, at initial position we have kinetic energy 3 by 4 mvcm square. Clear? And if I am talking about potential energy 0. Clear? But let's suppose I am saying here we have total height. Height is given to you or not? Not. Okay, fine. So okay, that's fine. So let's suppose I am saying this height we have h. Clear? So if we are talking about K final, clear? So how far will the cylinder? Definitely when the cylinder is moving in upward direction and acceleration due to gravity, and one component of acceleration due to gravity act in opposite direction, so we can say final velocity or final kinetic energy we will get 0. Clear? And if I am talking about U final, definitely you can say U final is given by mgh. Clear? So mgh. Clear? Now can we calculate value of h? Yes. Let's suppose I am assuming this distance covered is s. Clear? So I can say we can calculate here sin 30. Sin 30 equal to what? H by s. Clear? So s equal to what? H by sin 30. So here we can say this is mg and we can say s upon sin 30. Clear to you? We can write like this, mgh this one, clear, sin 30. Sin 30 equal to h upon this one. Actually here we will write in multiplication. Clear? So here you will get this mg or yes mg as sin 30. Clear? So now you can observe here initially we have only kinetic energy, clear, and after reaching at the maximum height point, or we can say after covering some distance, its kinetic energy becomes 0, but all kinetic energy, because this is moving under the influence of gravitational force, it means conservative force, it means we can say all its kinetic energy is converting into potential energy, clear. So now we can write like this: 3 by 4 m VCM whole square, this should be equal to mg s and divided by 2, clear. We can say m and m, this one is cancelled out, clear. So now we can say yes. Now we can write like this: 3 by 4th of VCM square, this is given by 1 by 2 GS, clear. Now what is first part in this question? How far the cylinder go up the plane? It means our objective here is to calculate value of S. So S, this is given by, we can say this one is 2, so 3 by 2, we can say this is VCM square, clear. S equal to what? We can say 3 by 2 VCM square, and it is divided by G, clear. So now we can write like this: 3 by 2 multiplied VCM, so center of mass velocity given 5, so 5 multiply 5, I can divide with 10, I can say this is 2, clear. So this is 15 by 4, clear to you? This is 15 by 4, I can say 15 by 4, clear. Or directly we can say here we have a total distance 3 we have 3 left, so 3.75 meter, clear. So total distance covered by this solid cylinder before coming to rest, that is given by 3.75 meter. Part number B, and in part number B it is given to you how long will it take to return to the bottom, clear. So now concentrate, clear. Now listen carefully. Our objective in this question is to calculate total time taken to reach at the bottom again, clear. So now you can say, let's suppose again if I am drawing here this inclined plane, this is given to you 30 degree, here we have a solid cylinder, this solid cylinder is having certain center of mass velocity, it is going up to a certain distance and again coming to this point, clear. So I can say we can calculate here total time like this: first total time taken by this cylinder to move from point A to B, and again total time taken from B to A, clear, and we can get our answer, clear. Now you can say actually this solid cylinder is moving under the influence of gravitational force, so we can say that is constant acceleration, it means we can apply equation of motion. So first A to B, listen carefully, A to B I am saying here, we can write here that final velocity I have 0, clear. If I am talking about initial velocity, we have VCM, clear, minus, let's suppose because that is going in an upward direction, acceleration is actually acting in opposite direction, or we can say here we have retardation, so we can say this is AT, clear. So from here we can say acceleration is given by VCM divided by T, equation number 1, clear. Now we know total distance covered, we assumed here that is S, so I can also apply here second equation of motion or third equation of motion. I can say here we have final velocity 0, initial velocity given V center of mass whole square minus 2A, and distance covered is S, clear. So now from here we can write like this: 2AS, this is given by V center of mass whole square, clear. So now we can say acceleration, that is given by V center of mass whole square divided by twice S, clear. Now we can say acceleration. So if I am talking about equation number 1 and 2, we can say equation 1 and 2 both are left hand side is same, it means we can say right hand side is also same. So VCM divided by T, this is equal to VCM square divided by twice S, clear. So 1 CM 1 VCM, this is cancelled out. So now what is value of we can say time T. So time T, this one is given by 2S divided by VCM, clear. Total distance covered we have already calculated 2.75, and VCM is given, this is 5, clear. So now we can say if we multiply this one we can say that becomes 0, we have 1, that is 15, and we can say 7.5. Clear? So 7.5 divided by 5. So we are having total time 1.5 second. Clear? So this is what is the time. Actually this time is denotes total time taken by this sphere to move from point A to point B. Clear? But what is total time taken? What I am saying to you, if I am talking about total time taken, so total time taken, this is given by TAB plus I can say TBA. Clear? It means let's suppose this solid cylinder is taking total time 1.5 second when it is moving in an upward direction. So again it is going to the bottom with the same time. It means if I am talking about total time taken will be 1.5 plus 1.5. So this will be 3 seconds. Clear? So this is all about this question. Now student, we are going to discuss question number 7.22, and in this question it is given to you as shown in figure, the two sides of a step ladder BA and CA that is given to you are 1.6 meter long. Clear? So we can say length of this BA and CA that is given to you 1.6 meter. Keep in mind. Clear? And hinged at point A. Okay, fine. A rope DE 0.5 meter is tied halfway up. Clear? It means it is given length of this rod that is 0.5 meter. Clear? And it is tied at the midpoint of AB. Clear? Okay. Now it is given a weight of 40 kg is suspended from a point F as shown in a figure. Clear? And it is having a position 1.2 meter from B. Okay. So first let us try to mention here all the dimensions. Clear? So it is given in a question. I am just telling you this is 1.6. Just I am not writing here meter because there are so many parameters here. We have to just identify all the given distances. Clear? Now it is also given 1.6 meter, that's fine. A rope DE, this is 0.5 meter. So this is given to you 0.5. Okay, fine. Clear? It is tied at halfway up, means we can see this value we have 0.8. Clear? Then a weight of 40 kg is suspended that is given to you. Clear? At from a point F 1.2 meter from B. Clear? So from here we can say this point is given to you 1.2 meter. Clear? Okay, fine. Assuming the floor is to be frictionless, it is given in a question, we have to assume this floor frictionless. Fine. And neglecting weight of a ladder, find the tension in a rope and force exerted by floor on the ladder. Clear? So first let us try to find again if I am drawing here one diagram. So what is the different forces that is acting here? Listen very carefully. Clear? So if I draw here, yes, so if I draw here this one, let's suppose if I draw here a forces that is acting. So I can say here one force this is acting here, that is known as NB. Clear? Here we can say one more force this is acting, that is NC. This force is exerted by ground. Clear? Now we can say more force that is acting here. Definitely here we have one force, and that force is the W. Clear? Here we can say force that is acting here, this is tension force T. Clear? And more forces that is acting here? No. So this is all about all the forces. Clear? So now from here we can say can we write here one equation? Yes, equation we can say, you can understand here, that is we can write NB plus NC that is given equal to W. Clear? In this question it is given NB plus NC, this should be equal to W. Clear? And W, it is given to you 40 kilogram. So we can say 40 multiply G, I can say this is 40 multiply 9.8. Clear? So now we can say this is equal to 4 multiply 98. So we can say this is 2, we have 392. Clear? So now we can say here we are getting one equation NB plus NC, this should be equal to 392, and let's suppose this is equation number 1. Clear? You always keep in mind this is also equal to weight. Clear? So weight we have 392 Newton. Clear? Now if I observe here rod AC, listen very carefully. Clear? So if I drop here a perpendicular from this side like this, clear, and I can say this one, clear. So now what I am taking here, I am taking a torque with respect to A, clear. I am taking here torque with respect to A, clear. Now we can say, we can write like this, let's suppose this is AC and I am saying let's suppose this is P, clear. So now we can say if I am talking about torque about point A, we can say NC and its perpendicular distance, that is PC, clear. So NC perpendicular distance is given to you PC, clear. Now if I am talking about more forces, here we have a tension and perpendicular distance. If I am talking about perpendicular distance, then I can say perpendicular distance for this tension, that is given by, listen carefully. So now we can say this is tension T and this perpendicular distance I am saying, let's suppose this is Q. So I can say this is AQ, clear. So we can say minus T, clear. Okay, because from the with respect to point A, we can say this is anti-clockwise direction, this one is clockwise direction. So tension T and AQ, and I can say this is equal to 0 because we have only these two forces, clear. And we are actually neglecting mass of this ladder, clear. So from here we can see NC into PC. So can we find here value of PC? Yes, because we can say if this distance is 0.5, listen very carefully. Now we can say this distance, if I am talking about this distance is half of this distance, clear. So this distance and we have this distance, so definitely we can say PC equal to 2 times of QE, clear. So directly you can say here value of PC we are getting 0.5 meter, clear. So I can say NC multiply 0.5 minus tension T and AQ. Now can we calculate value of AQ? Yes. How? We can say this is 1.6, clear, and this is 0.8. So definitely if I am talking about right angle triangle AQD, I can say this is 0.8 and we can say this is 0.25. So directly we can find out. So I can say value of AQ, this is given by under root of 0.8 whole square. We can say this is 0.8 whole square and 0.8 whole square minus, I can say this value we have 0.25 whole square, 0.25 whole square, clear. So now you can apply here a square minus b square formula, a minus b, a plus b. So a plus b, I can say this is 1.05, clear, and I can say this is 0.55, clear. So if you multiply, you can easily get here value of AQ, clear, and definitely you will get here this is 0.76, clear to everyone. So you will definitely get this value 0.76. So I am saying this is 0.76, this should be equal to 0. So from here you can say NC multiply 0.5, this is equal to tension T 0.76, clear everyone. So from here can we calculate value of tension? Yes, surely. So tension value T, this is given by we can say 0.66 and we can say NC, clear. So this is again a very important equation for us, clear, yes or no? Now so I think this is clear to everyone. Now here I am writing just important parameters here that is required for us. I am saying here I am writing whatever. Yes, I am writing here this is NB, just a minute. Yes, now you can say actually we have here two equations. This is equation number 1, we have equation number 2, clear. Now what is our objective in this question? Our objective is very clear, that we have to calculate tension in a rope. It means if we calculate first NC value, definitely we can get here value of tension, clear. And second point, if we calculate here force exerted by floor, it means we have to calculate NB and NC value, clear. So now listen carefully. Now if I am talking about a ladder that is AB, clear, I am talking about this ladder. I am not rubbing this all these value because all are important for us. So if I am talking about AB, clear, so can we take a torque about point A? Yes. So now listen carefully, just I am erasing some part. so that we can get all the details here. Yes, just this one. Clear? Yes. Now listen carefully. Yes. Now if I am talking about torque, I am taking here torque about point A. I can say here, I can write like this, NB and multiply. NB multiply this perpendicular distance, this is equal to 0.5. Clear? If I am talking about tension, so I can say I am taking minus, because this is in a clockwise direction, this is anti-clockwise direction. So tension multiply this AQ. AQ, this is, we have calculated 0.76. Clear? And here we have one more term, that is W. Clear? So here we can write W. So W is also in anti-clockwise direction. Yes or no? So I can say minus W into, clear, this perpendicular distance. Now very important. Actually we have here, this is 0.5. So we can say this is 0.5 divided by 4. Yes or no? So we can say this is 0.5 divided by 4 and this should be equal to 0. Clear? So from here you can write like this, NB into 0.5, this is equal to tension T 0.76 plus W 0.5 divided by 4. Clear to everyone? Yes or no? So let's suppose I am saying this is equation number 3. Clear? Now listen carefully. First count here number of variables. Number of variables we have, this is NB and NC, we have 2 variables. Clear? Here we have tension T. Clear? Third variable, W is already know. Clear? We have 3 variables and we know here 3 equations. Clear? We know here 3 equations, and we have 3 variables. So definitely we can solve here all the values of tension, NC and NB. Clear to everyone? So hope you can solve it. Yes or no? It's just a simple calculation. NB plus NC equal to 392. NB multiply 0.5. This is equal to tension T 0.76 plus W 0.5 by 4. Or we can say tension T, this is given by 0.66 times of NC. Clear? I am directly writing here all the values. So concentrate here. I am directly writing here all the values. Clear? Now listen very carefully. Yes. So if I write here, because our objective here is to calculate NB, NC and tension T. I am writing all the 3 values. Clear? You can easily calculate. So this value we can say NB. NB means normal reaction that is acting at point B. This one is given by 245 Newton. Clear? If I am talking about NC, NC we can say this is equal to 147 Newton, and if I am talking about tension T, this is equal to 97 Newton. Clear? So if you solve all the 3 equations, definitely you can get these values. Clear to everyone? So this is all about this question. Clear? Now students, we are going to discuss question number 7.23, and in this question it is given to you, a man stands on a rotating platform. Clear? Let's suppose we have a man, and man is actually stands on a rotating platform with his arm stretched horizontally, holding a 5 kg weight in his hand. Let us try to understand given situation. Let's suppose we have a rotating platform. Clear? And I am standing on this rotating platform. Let's suppose I have 2 weight in my both hands, and that platform is actually rotating like this. Clear? So at that time it is given, if I am considering myself as a platform, myself and platform, then the combined moment of inertia is given to you 7.6 kg meter square, and mass of each weight is also given to you, and the distance, initial distance is also given, that is 0.90 meter. Clear? Or you can say 90 centimeter. Clear? Now what will happen after some time? After some time we can say, whenever I am folding my hand like this, now distance of that weight from axis of this rotation, now it becomes only 20 centimeter. Now what is my objective? My objective here is to find new angular speed. Now let us try to understand. So actually if I talk about important point, first I will find initial moment of inertia. Initial moment of inertia, I can say it is given 7.6 for a main plus platform. Clear? mr square, we can say 5 r, it is given 90 into 10 to the power minus 2 whole square. Clear? mr square, and multiplied with 2, because I have 2 hands and I am holding both weights in both hands. Clear? Yes. So now we can see from here you can write like this, 7.6 plus 10 multiply I can say 90 divided by 100 whole square. We can say this one and this one cancelled out. So we can say 7.6 plus 10 into 9 divided by 100. Clear? We can say this one and this one cancelled out. Clear? So from here we can say 7.6 plus 8.1. Clear? So directly we can say 7 and this is 15. So I can say this is 15.7 and we can say kilogram meter square. Clear? So we can say this is initial moment of inertia. Clear? Now if I talk about final moment of inertia, at the time we can say 7.6 is a constant, but I can say distance from rotational axis of that weight is now changing. So I can say 5 20 into 10 to the power minus 2 whole square. Clear to you? So 7.6 plus 5 we can say this is 0.2. Clear? 0.2 into 0.2. Clear? So if you solve it, you can say 7.6 and we can say 5 into 2 by 10 into 2 by 10. This one and this one is cancelled out. We can say this is 0.2. Clear to you? Yes, actually always keep in mind here we have two weights. Clear? So we have to multiply it with 2 also. So this is 2 multiplied with 2. Clear? So now I can say here we are getting value 7.6 plus 0.4 and that is equal to 8 kilogram meter square. Clear? I can say 8 kilogram meter square. So this is final moment of inertia. Clear? Now it is also given, initially we have a rotational speed, that is revolution per minute. Always keep in mind this is given in a revolution per minute. You do not need to convert this angular velocity in radian per second because it will be cancelled out from both sides. Clear? Now you can say this is a situation given to you. If I am talking about moment of inertia, if I am talking about moment of inertia about this axis, rotational axis. So on this rotational axis we can say net torque acting is equal to 0. Clear? It means I can apply here conservation of angular momentum. Clear? So I am just writing here two values 15.7 and 8, that is important for me. So 15.7 and 8. Clear? So I can say I1 this is equal to 15.7 and we have this value 8, this value we have I2. Clear? I can write here for part number A I1 omega 1, this should be equal to I2 omega 2. Clear? So value of I1 this is given to you 15.7 into omega 1 30 revolution per minute, this should be equal to 8 multiply I can say omega 2. Clear? So omega 2 I can say 15.7 into 30 by 8. Clear? So this one we have 4. Clear? And we can say this is 15. Clear? So now if you multiply, you can directly say, or you can first divide it. We can say this is 3, we have here 3 left. Clear? So 3 left, we can say that is 3.9. Clear? So if you multiply it with 15, definitely you will get here values in revolution per minute. So we have 5, 13, so 45 or 13, that is 58. So 58.5 revolution per minute we are getting. Clear? Clear to you? So we can say this is new angular speed. Clear? Now important part, it is given is kinetic energy is conserved in the process. Generally you will find in this case kinetic energy increases. Why? Because as you are folding your hand, actually whatever your internal energy, that internal energy is actually converting into the kinetic energy of that platform. Clear? Or we can also calculate here like this. If I am talking about K1 over K2 ratio, I can say 1 by 2 I1 omega 1 square divided by 1 by 2 I2 omega 2 square. Clear? So value of I1 we know, that is 15.7 and that is 8. So 15.7 divided by 8 omega 1. Omega 1 is given 30 and this is 58.5. So 30 into 30 divided by, I can say 58.5 into 58.5. Clear? So just take an approximation. I can say this is approximately 16. So I can say this is 2. Clear? And let's suppose this is approximately 60. Clear? So I can say 1 by 2 into 1 by 2. So from here we can say this one and this one cancel out and we are getting this ratio 1 by 2. Clear? It means directly I can say value of K2 I am getting here, this is 2 times of K1. Clear to you? So it means we can say kinetic energy is not same as before. Clear? Actually kinetic energy increases. Clear to you? We are getting the same result? Yes. And actually why, from where that energy is coming, I already told you. Actually when we are lowering that weight, actually the work, or we can say the internal energy of our body, or whatever the internal energy we have, that is converting into kinetic energy of that platform. Clear? So this is all about this question. Now dear student, we are going to discuss question number 7.24, and in this question it is given to you a bullet of mass 10 gram and speed 500 meter per second is fired into a door. So let's suppose I am having here a bullet, clear, and mass of this bullet is given m equal to 10 gram, clear. It is actually moving with the speed, so v, this is given to you 500 meter per second, clear. Now we can say this is fired into a door, clear. So let's suppose I am saying here we have a door, clear, and this bullet is fired in a door, clear, and it is also given that door is 1 meter wide. So I can say here we have this distance 1 meter, okay, fine, and it is also given it is having weight. So mass of this door, that is also given to you 12 kilogram. Okay, fine, clear. It is hinged at one end and rotate about vertical axis without any friction. Fine. Now we have to find that angular speed of a door is what, clear. Now it is given here exactly, it is embedded at the center of a door, clear. At the center of a door, it means let's suppose this bullet is embedded at this position, clear. So definitely from this hinge point we will take here this distance, that is half of meter, clear. So now how can we solve this question? So actually we can apply here conservation of angular momentum, clear. So conservation of angular momentum, I can write like this: mvr, this should be equal to I omega, clear. My objective in this question is to calculate omega. So omega, this is given by mvr divided by I, clear, mvr, clear. Now what is moment of inertia about this axis? That is, we can say you know what is moment of inertia of a road about an axis that is passing through this end, that is ml square by 3. So I can write here this is capital ml square by 3, clear. From here I can say 3 mvr divided by capital ml square, clear. Now I can calculate here omega 3 small m, this is given to you 10 gram, so 10 divided by 1000 multiply. Now I can say v we can say that is 500 and multiplied with r, clear. So I can say r we can say this is equal to half, clear, because this bullet is embedded at the center of this rod, clear. So divided by ml square, m is given to you 12, clear, l square. Now value of l we can say that is 1 meter, so I can say this is 1 square, clear. From here you can say 0 0 0, this one is cancelled out, clear. So now from here we can say omega is given by, this is 3 multiply 5, I can say this is 15 divided by, we can say 2 divided by 12, so 2 divided by 12, clear. So if you cut with 3, we can say this is 5 and this is 5 and this one is 4, clear. So from here we can write like this is 5 by 8 and we can say this is 0.625, clear, radian per second, clear. So we can say this is angular speed of a door just after bullet gets embedded in a door and bullets is embedded at the center of this door, clear. So this is all about this question. Now student, we are going to discuss question number 7.25, and in this question it is given to you two discs of moment of inertia I1 and I2 about their respective axis, okay, normal to the disc and passing through center, that is given to you. It is rotating with an angular speed omega 1 and omega 2, okay. Now they brought in a contact face to face. Now we have to find that what is angular speed of two disc system, clear. So now you can understand this situation like this. Let's suppose here we have a disc, let's suppose I am saying this is disc, clear. It is having moment of inertia I1, clear, and let's suppose it is rotating with angular velocity omega 1, clear. Let's suppose here we have one more, let's suppose I am saying here we have one more disc, clear, having moment of inertia I2 and it is rotating with angular speed, that is omega 2. Clear? Now what I am doing here, actually I am sticking both this to each other. Clear? It means I can say now situation is like this. Clear? Let's suppose I am saying here we have this disk. Clear? Having I1, and here we have one more disk. Clear? And we can say this is I2. Clear? Now when both disks stick to each other, definitely we can say they are moving with the common angular velocity, this is omega. Clear? So now we can say here we can apply conservation of angular momentum, because about this axis we can say there is no external torque is acting. When there is no external torque acting, it means we can say angular momentum always remains conserved. Clear? So from here we can write like this: initial angular momentum, this is equal to final angular momentum. So initial angular momentum given I1 omega 1 plus I2 omega 2, this should be equal to, I can say I1 plus I2, and it is multiplied with omega. Clear? So now we can say omega, this is given by I1 omega 1 plus I2 omega 2 divided by, I can say I1 plus I2. Clear everyone? So omega we can say I1 omega 1 plus I2 omega 2 divided by I1 plus I2. Clear to everyone? Yes. So now we can say this is value we have, that is omega. Clear? Now I can say can we calculate here that this is a part A. Part A is, I think, clear to you. Clear everyone? Yes. Now if we talk about part number B, show that the kinetic energy of a combined system is less than sum of initial kinetic energy of two disks. Clear? So now we are going to solve part number B. Now listen carefully. Let's suppose if I write here initial kinetic energy, this is equal to half of I1 omega 1 square plus half of I2 omega 2 square. Clear to everyone? Yes. Now if I talk about final kinetic energy, this one given by half of I1 plus I2, and I can say this is omega square. Clear? In this question it is given kinetic energy of a combined system is less than sum of initial kinetic energy of two disks. Means we can find here loss in kinetic energy. Clear? And loss in kinetic energy is given by K initial minus K final. Clear? So K initial, I can write like this: half of I1 omega 1 square plus half of I2 omega 2 square minus, this is half, I can say I1 plus I2, and this one is omega square. Clear to everyone? Clear? So now yes, actually we can also write this expression here, this one. Clear? This is a pen. Yes. Now let us try to understand this derivation here. Clear? It is given in a question. If we are talking about initial kinetic energy is given by half of I1 omega 1 square plus half of I2 omega 2 square. Clear to everyone? Yes. Clear? But if I talk about final kinetic energy, clear? Final kinetic energy is given by half of I1 plus I2, clear, and it is multiplied with omega square. Clear? So if I find here loss in kinetic energy, clear? So how can we calculate? We can calculate like this: half of I1 omega 1 square plus half of I2 omega 2 square. Clear? And then we can write like this: minus half of I1 plus I2, this is omega square. Clear? Now we can put here value of omega. Clear? So we can write like this: half of I1 omega 1 square plus half of I2 omega 2 square minus 1 by 2 I1 plus I2, clear, and omega square. Now we know what is value of omega: I1 omega 1 plus I2 omega 2 divided by, we can see I1 plus I2. Clear? And this value we have square. Clear? So from here first of all we have to calculate I1 omega 1 square plus half of I2 omega 2 square minus 1 by 2 I1 plus I2. Clear? Now Now we can say actually this I1 plus I2 and this I1 plus I2 is cancelled out. Actually this is a square, so we can write like this. Yes, we can also write like this. Yes, we can also write like this. This is I1 omega 1 square, I1, yes, I1 omega 1, omega, just I1 square omega 1 square, clear, plus I2 square omega 2 square, plus we can say this is equal to twice of I1 I2 omega 1 omega 2, clear everyone, and it is divided by, I can say this is I1 plus I2 only, clear. Now if you take here LCM I1 plus I2 and if you multiply it with it, you can write like this 1 by 2. First I am multiplying with I1, so I1 square omega 1 square plus 1 by 2 I1 I2 omega 2 square, clear. Now I am multiplying with I2 plus 1 by 2 I1 I2, clear. This is omega 1 square plus I can say this is 1 by 2 I2 square omega 2 square, clear. Now we can write like this. This is minus I1 square omega 1 square minus I2 square omega 2 square, clear, and minus 2 I1 I2 omega 1 omega 2, clear, and we can say it is divided by, I1 plus I2, clear. Now you can say which one is cancelled out, here we have half, everybody we have half, so we can also write like this is half, clear. This one also divided by 2 and this one is also divided by 2, clear to everyone. Yes, now from here we can say I1 omega 1 square, clear, and this one cancelled out, clear. From here you can say this one and where is this one, this is cancelled out, clear. So now we can say I1 I2 omega 2 square, and here we also have I1 I2 omega 1 omega 2, okay. So from here we can take some common, clear. So now concentrate here, I am writing here. So we can take here common I1 I2 divided by, we can say here I am taking 2 times of I1 plus I2, clear. Now you can say here we have here omega 2 square plus omega 1 square, and here we are taking actually 1 by 2 outside, so minus 2 times of omega 1 omega 2, clear. So I can write like this, this is omega 2 minus omega 1 whole square, clear. And my dear student, this is equal to what? This is change in actually loss in kinetic energy, clear. So now we can say here I1 plus I2 all are positive, and we are getting here omega 2 minus omega 1, and this is whole square, it means this is also positive, it means we can say here the loss that we are getting, clear. So this is actually indicating loss of kinetic energy, or actually we will get this loss that is positive, clear. So this indicates that initial kinetic energy is more compared to final kinetic energy. So actually why this is happening, clear. Actually whenever we are actually connecting two discs, at that time some of its energy is actually dissipated in the form of heat when they touch to each other, and after some time when they reach up to a common angular velocity, clear. So there is some energy is to be dissipated due to friction, clear. So we can say this is all about this question, clear to everyone. Now dear student, we are going to discuss question number 7.26, and this is a question related to parallel axis theorem and perpendicular axis theorem, and in this question it is given to you prove theorem of perpendicular axis and prove theorem of parallel axis, clear. So first I am going to prove perpendicular axis theorem, clear. So concentrate on a screen. Let's suppose I am taking here, let's suppose this is a body, rigid body, let's suppose, clear, and I am taking here x axis in this direction, we can say this is y axis, and let's suppose I am taking z axis in upward direction, clear. Now we know this is a rigid body, this is made up of a number of particles, clear. So for convenience I am taking here only one particle, let's suppose this one, clear, and Now we can say, and let's suppose coordinate of this particle we have this lie in a xy plane. So I am saying here, let's suppose x comma y. Clear? Now we can say this point is situated at what distance from this x-axis. So definitely I can say this distance we have y. Clear? Now if I talk about this distance, definitely I can say this is x. Clear? Because this is parallel to x-axis. Clear? And let's suppose I am assuming this distance we have, that is r. Clear? Now you can say actually x-axis and y-axis both are perpendicular to each other. It means now we can also write like this, value of r, this is given by under root of x square plus y square. Clear? So first if I write here moment of inertia about x-axis, so I am writing like this, moment of inertia about x-axis, that is given by m, and what is this distance, that is y square. So I can write like this is y square. So actually this is moment of inertia at a particular of a particular body. Clear? Actually if I writing here mass, so let's suppose I am taking here a very small m, or let's suppose I am taking a mass, that is m. Clear? Now we can say here we have a rigid body, there is an infinite number of particles are here. Clear? So we can write like this is equal to summation of m y square. Clear everyone? We can write like this is equal to summation of m y square. Clear? Now if I say what about Iy? Clear? What about Iy? I can say this is equal to m times of x square for a single particle. But if I am talk about a complete lamina, at the time I can say this is equal to summation of m x square. Clear? Now if I write same for moment of inertia about z axis, at that time I can say this is equal to mr square. Clear? So if I talking about complete lamina, I can write like this is summation of mr square. Now you can put value of r from here, so we can also write like this Iz, this is given by summation of m x square plus y square. Clear? Because value of r we have under root of x square plus y square, and if we square it we can write like this. Clear? So now we can say Iz, this is given by summation of m x square plus I can also write like this summation of my square. Clear? So Iz. Clear? So if I am talking about Iz, I can say summation of mx square. So this value we have, that is Ix, plus I can say this is given by Iy. Yes or no? So because summation mx square, we can say this is equal to Iy. So you can write like this is Iy and this one is Ix. Clear to everyone? Clear? Now we can actually write like this is summation of mx square, so this is Iy and this is Ix. Now let us try to understand, this is expression of perpendicular axis theorem. Clear? So what this theorem says. Clear? So now you can say here moment of inertia, we can say actually x axis and y axis both are lying in a same plane, and this z axis is actually perpendicular to this plane. Clear? Number one thing. And we can say moment of inertia about this axis, that is equal to summation of moment of inertia about y axis plus moment of inertia about x axis. Clear? So directly you can say Iz, this is given by Ix plus Iy. Clear to everyone? So this is a proof of perpendicular axis theorem. Clear? You can easily find this application. Let's suppose here we have a disk. Let's suppose I am taking this disk. Let's suppose I am saying to you what is moment of inertia of this disk having mass m and radius r about this axis perpendicular to this screen. You can say, sir, this is mr square by 2. Clear? But let's suppose if I say what is moment of inertia about an axis that is passes through the center, or it is a diameter. Clear? So let's suppose I am saying this is x dash. You can say, sir, I x dash, this is given by mr square by 4. Why? Because we can say in this plane we have two axes, x axis or y axis, and both are having same moment of inertia, and this perpendicular moment of inertia about this perpendicular axis, this is given by mr square by 2. Clear? So it will be equally divided. Clear? So like this we can use this perpendicular axis theorem. Clear to you? Now we are going to discuss part number B, or we are going to prove the theorem of parallel axis theorem. Clear? So now concentrate on a screen. Now listen carefully. let's suppose if I am talking about part number B, let's suppose this is a body, clear, and let's suppose here we have center of mass of this body, clear, and let's suppose I am saying here, let's suppose I am saying moment of inertia about the center of mass we have ICM, clear. Let's suppose if I am talking about at any point P, and at this point we have a mass small m, clear, and now let's suppose this is situated at a distance small d from this center of mass, clear. Now let's suppose I want to find moment of inertia about an axis, and this is PQ, let's suppose, clear. So I am saying moment of inertia about this axis we have I, clear. So how can we find moment of inertia about this axis PQ? I can directly say I, this is given by m and r square, mr square. R square means we can say, let's suppose I am saying distance between these two parallel axes, that is x, clear. So I can say this is x plus d whole square, clear. Now we can say this is only for a small mass, clear. Now let's suppose if I combine all the mass, at that time I can write like this, I, this is given by summation of m x plus d whole square, clear to you. So now we can also write like this, summation of m x square plus d square plus twice of xd, clear everyone. So now we can also write like this, m x square plus summation of md square plus 2 times of summation mxd, clear. Now listen carefully, summation of mx square, summation of mx square. So what is this? I can say x value is a constant, the distance between this axis and this center of mass is fixed. I can say this is actually you can say like this, just a minute. Yes, now we can say actually if we are talking about summation of mx square, it means we can say this is a distance, or we can say this is distance. I am saying this is actually related to we can say that is ICM, clear. This is moment of inertia about center of mass, clear. Now we can say this is the distance d, clear. So distance d, I can say this is md square, clear, plus whenever I am saying xd, clear. So about center of mass we can say if you are doing the product of this distance x into actually you can also write like this, clear. 2, I am taking this d common, summation of mx. Now listen carefully. Now we know center of mass is represented by m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3, clear. But here you can say about center of mass this value we always find equal to 0, clear. So directly we can say I, this is given by ICM plus md square, clear. So you can easily apply this expression. This is the expression of a parallel axis theorem. So now let's suppose I want to find moment of inertia about axis, that is PQ. So I can write like this, I, this is given by ICM plus m into d square, clear to you. I can directly write ICM equal to I equal to ICM plus md square, clear. So directly if we talk about application part, listen carefully. So if I talk about application part, let us try to understand how can we apply this parallel axis theorem, clear. Proof is I think clear to you. Proof is very simple, but important part we have how can we apply, clear. So now let's suppose I am talking about this is a ring, for example this is a ring, clear, and let's suppose this is a center of mass, clear. I know a moment of inertia of a ring about its center of mass about an axis passing through its center, clear, and perpendicular to this plane, and you know this is mr square, clear. I am saying let's suppose mass m and radius is r, clear. So let's suppose I want to find moment of inertia about an axis that is tangential to this ring, clear. So at that time first I will find here ICM like this, but this axis should lie in the same plane. So we know about this axis we have moment of inertia mr square. So what is moment of inertia about this axis, that is mr square by 2. We are using perpendicular axis theorem, and we know this distance we have r. So let's suppose I want to find this I can directly say I, this is given by mr square by 2. This is ICM plus m, and distance between these two axes, that is given by r. Clear? So I can say I, this is given by 3 by 2 mr square. Clear? So like this we can apply this parallel axis theorem also. Clear to everyone? Now dear student, we are going to discuss question number 7.27, and in this question it is given to you, prove the result that the velocity v of translation of rolling body like a ring, disc, cylinder or a sphere at the bottom of an inclined plane of a height h, this is given by this expression. Clear? So now we are going to derive this expression, so concentrate on a screen. Yes. Now listen carefully. Let's suppose first I am drawing here an inclined plane. So just a minute. Yes. Now listen carefully. Let's suppose I am drawing here an inclined plane. This is an inclined plane. Clear? And let's suppose this inclined plane is making an angle theta. Clear? And let's suppose here we have an object. Let's suppose I am taking a sphere. We can take any body. It may be a ring, it may be a disc, it may be a cylinder, it may be a solid sphere. Clear? So I am taking here, this is a any object. Clear? Now we can say here, if we talk about different forces this is acting on this body, I can say here one force is acting in this direction, that is mg. Clear? And after that we can take here two components of this force, one in this direction, another one in this direction. Clear? I can say this angle is also theta. Clear? So now I can say this is mg cos of theta, and we can say this is mg sin of theta. Clear? We can also take here, we have here a normal reaction also. Clear? Now we can say actually we place this object on an inclined plane, definitely it is moving in a downward direction. So let's suppose when this object reaches at this point, I am saying total distance covered, that is s. Clear? And now we can say from here to here I am also taking here this distance, that is h. Clear to everyone? Yes. Now we can say let's suppose I am assuming here this surface is a rough, or we are also saying that actually this body is doing translation as well as rotational motion. So definitely I can say here one more force this is acting in this direction, that is friction force. Clear? So can we here write net force in this direction? Yes, we can write like this. This is, let's suppose I am saying mg sin of theta minus friction force, this should be equal to mass into acceleration. Clear? So now I am saying, let's suppose acceleration of this body in a downward direction we have a. Clear? So we can see, let's suppose this is equation number 1. Clear? We have one more equation, you can see n equal to mg, and we can say this is cos of theta. Clear? Now you can also see actually this body is rolling due to this friction. Clear? So can we write here value of torque? Yes. So value of torque, that is given by, we can say I alpha, or you can also say here friction force is providing necessary torque, so friction force and multiplied with r. Clear? So from here can we write here value of F? We can write like this, I alpha divided by r. Clear? Now actually if we are talking about perfect rolling condition, so in perfect rolling condition we can say A equal to R alpha. Yes. So we can also write like this, this is I A, and we can see alpha equal to A by R. So we can say this is I A upon R square. Clear? So this is a friction. So now I can put this value. Let's suppose if we are using equation number 1 and 2, and we can write like this, mg sin of theta minus value of friction we are having Ia upon R square. Ia upon R square. Clear? And this should be equal to ma. Clear to everyone? Yes. So from here I can say, we can write like this, acceleration, this is given by m plus I upon r square, clear, and this should be equal to mg sine of theta, clear. Now let's suppose I am writing here this moment of inertia in terms of radius of gyration, clear. So at that time I can write like this: a, this is equal to m plus m k square divided by r square, and this is equal to mg sine of theta, clear to you. So from here we can say m and m, this one is cancelled out, clear. So acceleration value, this is given by 1 plus k square upon r square, and this is equal to g sine of theta, clear. So value of acceleration we can say this is given by g sine theta divided by 1 plus k square divided by r square, clear. So we can say this is acceleration of this body that is moving downward direction, this is given by, clear. So this is expression of acceleration. But now what is our objective? Our objective here is to calculate velocity of this body when it move to the bottom, clear. So now listen carefully. Now we can see if we apply here equation of motion, why? Because you can say theta is a constant for this inclined plane and all other parameter is also constant. So I can say here that if we apply here equation of motion, clear. So equation of motion, I can say we can write like this: v square equal to u square plus 2as, clear. I am assuming here this body is starting from rest, so I can say this u equal to 0, clear. So we can say v square, this is equal to 2, acceleration is here g sin theta upon 1 plus k square upon r square. So g sin theta divided by 1 plus, I can say this is k square upon r square, clear, and we are having here value that is s, total distance covered is s, clear. Now you can say if this is h, we can also draw h like this, clear. And let's suppose if I talk about right angle triangle, clear. So in a right angle triangle we can say if I calculate here sin theta is given by sin theta is given by h upon, I can say s, clear. So I can write here value of h, this is given by s sin theta, clear, s sin theta. So s sin theta instead of n sin theta, now I am writing here value small h, clear. So I can also write like this: v square, this is given by 2gh divided by 1 plus k square divided by r square, clear to you. So this is a required expression, clear. So like this we can find here value of velocity of an object when it is reaching to the bottom on an inclined plane, clear. Now let's suppose if I say to you, let's suppose if we put here value of k equal to 0, it means now we are not taking moment of inertia into consideration. So let's suppose I am assuming this body is just doing a rectilinear motion. At that time you will get here v equal to under root of 2gh, clear to everyone. So same expression you are getting as you are getting in a rectilinear motion, clear. So my dear student, this is all about this question, clear. Now dear student, I am going to discuss question number 7.28, and in this question it is given to you: a disk rotating about its axis with angular speed omega naught is placed lightly on a frictionless table. Okay, fine. The radius of a disk is given to you capital R, and what are linear velocity of a point A, B and C on a disk as shown in a figure, clear. Will the disk roll in the direction indicated, clear. So let us try to understand first this question. Now we can say, you can see here this is a center of mass, clear. We can say this is a position of center of mass of a disk, clear. First I am talking about point A, and if I am talking about linear velocity, I can say this is given by VA, this is equal to R, and we can say this is omega naught, clear. So this is a linear velocity VA equal to R omega naught, clear to you? Yes. So we can say directly VA equal to R omega naught, and we can say in a right direction, clear to you. Now if I talk about point B, clear. So in the B we can say here tangential, this linear velocity in a left direction, and again we have same magnitude B, this is given by R V naught, clear. So I can say this value we have in a left direction, Clear to everyone? Yes. And what about point C? Clear? So I can say VC, this is given by R by 2 and this one is omega naught. Clear to you? Here you can see that tangential velocity or velocity in this direction, this is given VC, this is R by 2 and omega naught. Clear to you? So now we can say like this, we can write here all these linear velocities. Clear to everyone? Now in this question it is also asking, will the disk roll in a direction as indicated? Clear? So always actually concentrate on this word, perfectly frictionless surface. So actually here if we have a rough surface, at that time friction will provide actually friction will oppose this linear velocity. At that time you will find a perfect rolling condition. So because it is given here we have a frictionless surface, it means there is no rolling possible. Clear? So we can say here again, definitely this this body will not roll as in a direction that is indicated to you. Clear? Because this surface is a perfectly smooth surface. Clear? So this is all about this question. Now dear student, we are going to discuss this question, and in this question it is given to you, explain why friction is necessary to make the disc roll in a direction that is indicated. Okay, number 8. So first of all, our objective here in this question is to understand why friction is required if we are talking about rolling. Clear? So my dear student, if I am talking about pure rolling, in a pure rolling case, definitely we can say at this point, at the point of contact, at this point we should have relative velocity, it should be 0, or we can say velocity of this point B with respect to this one, it should be 0. Clear? Now we can say if we talk about velocity, this is indicating in this direction, that is R omega naught. Clear? So actually friction force is required because torque will act on that ball. Actually we can say this body will rotate only when torque will act on it. Clear? And for the torque we need a force that is tangential to this surface. So here only there is one possibility, that if there is a friction, it will act like a tangential force and it will actually it will produce a torque. Clear? So friction force is actually necessary if we want to roll this body. Clear to everyone? So this is all about part number A. Clear? Give the direction of friction force at B. So always keep in mind, the direction of friction force is always in a direction of B center of mass, or we can say actually the direction of friction force is like this, it will oppose the angular torque. Clear? So it will actually oppose the velocity at the point of contact. Clear? So now we can say this is all about part number A. Clear? Now second part, what is the force of friction after perfect rolling begins? Now listen carefully. Actually in start this friction force will act when at this point of contact. So friction force, what is the actually use of friction force? Friction force actually decreases this tangential velocity. So when relative velocity at point B, this becomes 0, at that time we can see the pure rolling condition achieved. Clear? So in the condition of pure rolling, the friction plays a very important role. It actually opposes or it actually decreases this velocity. Clear? And when this velocity becomes 0, at the time the friction also becomes 0. Clear? So actually we can say the purpose of a friction is to bring any object in a pure rolling condition. As the pure rolling condition is achieved, we can say this friction force becomes 0. Clear to everyone? So this is all about this question. Clear? Now dear student, we are going to discuss question number 7.30, and in this question it is given to you, a solid disc and a ring, both of having radius 10 cm are placed on a horizontal table simultaneously. Clear? So now we can say, let's suppose I am assuming, let's suppose I am saying this is an object, it may be a disc, it may be a ring. Clear? So in this question it is given a solid disc or a ring, both are having radius. So I am assuming radius first, that is capital R. First of all I am actually finding here a formula that is related to that time. Clear? So a solid disc and ring both are having radius 10 cm are placed on a horizontal table. Okay, fine. Initial angular speed is also given, it means omega naught is also given to you. Okay, and which of the two will start earlier? Clear? And coefficient of kinetic friction is also given. Okay, now concentrate on a screen. And let's suppose we are talking about pure rolling condition. Clear? So let's suppose first I am talking about this is V center of mass. Clear? And if I am talking about pure rolling condition, in pure rolling condition at point B we should V center of mass, it should be equal to R omega. Clear? So at that time actually the use of this friction, is to bring this body in a pure rolling condition. Once the pure rolling condition is achieved, this friction force becomes 0. Clear? So I can say we can write like this V center of mass. So V center of mass, this should be equal to R omega. Let's suppose this is equation number 1. Clear? Now when a body just start and in a condition of a pure rolling, the role of friction is very important. Clear? So we can actually write like this: friction force, this actually providing necessary acceleration for center of mass. So I can say this is equal to m into a. Yes or no? Yes. So now we can say m into acceleration a. Clear? Now we know friction force. Friction force is actually written as mu mg. Clear? So from here we can say m and m, this is cancelled out. Clear? So necessary friction force, that is equal to, or we can say this acceleration of center of mass, this is equal to this one. Clear? Now I can also write like this: this is the acceleration value. Clear to everyone? Yes. Now we can say actually this friction force is also providing a torque. Clear? So I can say torque, that is given by F into R, and we can say this is the R. Clear? Perpendicular distance R, and we can say this is in anti-clockwise direction, and actually this is retarding the motion. So we can say this is equal to minus times of I alpha. Clear? So we can also write like this: alpha, this is given by minus F R by I. Clear? Value of friction force, this is given to you mu k mg. Clear? So we can write like this: alpha, this should be equal to minus mu k mg R divided by I. Clear to everyone? Now we can also write like this: omega equal to omega naught plus alpha t. Clear? So now we can say omega, we can also write value of omega, this is equal to V by R equal to omega naught, this is given to us. Clear? Plus alpha. Now we can put here value of alpha, this one. So this is minus mu k mg R divided by, I can say I. Clear? And it is multiplied with t. Clear? Value of V, what is value of V? We can put value of V like this. Clear? We know V equal to U plus AT. Clear? Value of acceleration we have mu k into g. So I can say this is equal to mu k gt. Clear? So I can put that value here. Clear? So mu k gt divided by R, this is given by omega naught minus mu k mg R by I and multiplied with t. Clear? It is multiplied with t. Clear? So from here you can say we can take here common mu k gt. Clear? So from here I can write like this: this is 1 by R. Clear? Mu k gt I am taking common 1 by R, and mu k gt from here, so plus m R divided by I. Clear? Clear? And this should be equal to, I can say, omega naught. Clear? So if I take here common, that is R also. Clear? So I can write here this value R, and from here we can say this R is here not, and we can also write like this: here we have R square. Clear to you? So from here can we calculate, can we find here value of t? Yes, definitely. So how can we write value of t? Listen carefully. Yes. So from here we can say value of t we can write, and value of t how can we write, that is very important. Yes. So value of t I can write like this: t, this should be equal to R omega naught divided by mu k, and this one is g. Clear? And 1 plus m R square divided by I. So my dear student, actually I derived here a general expression that is related to time t. Clear? Now if I talk about disk, listen carefully. If I talk about disk, clear? So at disk we can say this I equal to mr square by 2. Clear? So I can say this is given by r omega naught divided by mu kg. Clear? This is mr square by 2, so I can say this is equal to 3. Clear? And this is a time for disk. Clear? Now let's suppose if I am talking about ring, and if I calculate here value T2, then for a ring I can say this is equal to mr square. So mr square and mr square, this is cancelled out, this is becomes 2. So I can say r omega naught divided by mu k g, and this is 2. Now you can say here, if we compare both time taken by disk or a ring, definitely we can say time taken by disk is less compared to this ring. Clear? It means I can say disk will reach it first. Clear? Disk will reach first, disk will reach earlier compared to this ring. Clear? From an incline, from or we can say it will actually roll earlier. Clear? So which one roll earlier? Definitely I can say disk will roll earlier compared to the ring. Clear? Now can we calculate here values? Yes, definitely we can calculate. So how can we calculate? Let's solve it. Yes. Listen. So if we first calculate value of T1, we can say value of R. Value of R, this is given to you, yes, 10 centimeter. So 10 into 10 to the power minus 2. Value of omega naught. Omega naught is given 10 pi. It is divided by, I can say this is 3 times of mu kg. So 3 into value of mu k 0.2 and multiplied with g. G value is given, that is 10. Clear? This one and this one cancelled out. Clear? So from here you can say, we can write like this. This is 10 to the power minus 1. This one and this one. All are cancelled. Clear? So from here you can say this is pi by 6 second. Clear? Similarly you can calculate for value of T2. Value of T2 we can say this is given by R. Value of R we have 10 into 10 to the power minus 2. Omega naught is 10 pi divided by, we can say 0. Value of mu k is 0.2. Clear? Multiplied with 2, and we can say value, this is G10. Clear? So from here we can say this one and this one cancelled out. This all are cancelled. Clear? And we can say this is equal to pi by 4 second. Clear? So definitely we can say T1 is less compared to T2. So like this we can solve this problem. Clear? Now dear student, I am going to discuss question number 7.31, and in this question it is given to you, a cylinder of mass 10 kg and radius 15 cm is rolling perfectly on a plane of inclination 30 degree. Clear? Coefficient of static friction is also given to you. Number 1, how much force of friction acting against a cylinder? Clear? So let us try to solve this question. Now concentrate on a screen. Let's suppose I am saying here, this is an inclined plane. I am assuming here, let's suppose this angle is theta. Here we have any body. Let's suppose if I am talking about solid cylinder. So let's suppose this is solid cylinder. Clear? If I am talking about forces, I can say here mg force is acting. Clear? So we can say if this angle is theta, I can say this is mg cos of theta, and we can say this is mg sin of theta. Let's suppose this body is actually going, or we can say center of mass of this body is going with acceleration a. At that time we can say friction force will act in opposite direction like this. Clear? So we can say, we can write here mg sin theta minus f, this should be equal to ma. Clear? Now you know, whenever we are talking about translation plus rotational motion, acceleration a, this is given by g sin theta upon 1 plus k square upon r square. Clear? So because it is given here, this is solid cylinder, this is given here a cylinder, it means I am assuming this is solid cylinder. Clear? So for solid cylinder, what is radius of gyration? I can say mk square, this is given by mr square by 2. Clear? From here we can say k square equal to r square by 2. So acceleration a, this is given by g sin theta divided by 1 plus. Clear? So 1 by 2. Clear? If I take here LCM 2, then we can say this is equal to 2 by 3 g sin of theta. Clear? So from here can we calculate value of friction? Yes. mg sin of theta minus f, this should be equal to m, I can say 2 by 3, this is g sin of theta. Clear? Clear to you? So we can say this is equal to g sin of theta. Clear? So Now we can say it means value of friction force, this is given by mg sin theta minus 2 by 3 mg, this is also sine of theta. Clear? So we can say friction force, this is given by 1 by 3 mg sine of theta. Clear? F equal to 1 by 3 mg sine of theta. Clear to you? So now we can say, we can put here all the values and we can get our answer. Clear? Now listen carefully. Yes. Now we can say here, if I am talking about part number A, friction force F, this is given by 1 by 3 mg sine of theta. Clear? So 1 by 3, okay, mg sine theta, value of m, this is given to you 10. Okay, if we talk about g, that is 10. Clear? And sine, we can say angle of inclination is given 30 degree. So now we can say this is 1 by 2, so 100 by 6 Newton. Clear to you? So we can say this is value of friction force we have. Clear? So now second part, we have what is work done against friction during rolling. So if we are talking about perfect rolling, so whenever we are talking about pure rolling, in pure rolling case, friction force acting at a point of contact, that becomes 0. Clear? Because actually work of a friction is only this one, that it actually bring that body in a pure rolling condition. Clear? So I can say here, whenever friction force is 0, itself 0 in a pure rolling case, I can see work done, this is equal to 0 joule. Clear to you? Now in this case it is given, if inclination angle theta of a plane is increased, okay, at what value cylinder begins to skid. Clear? So actually what is condition? Condition is very simple, whatever friction force this is acting, it should be less than equal to mu k n. Clear? Or you can say friction divided by normal reaction, this should be less than equal to kinetic friction. Clear? Value of friction force is given 1 by 3 mg cos of mg sine of theta. Clear? It is given to you, this is mg sine of theta. Clear? And it is divided by, I can say, mg cos of theta, and this should be less than equal to 0.2. Clear? This should be less than equal to 0.25. Clear? So from here we can say this one and this one cancelled out. Clear to you? Now yes, so now we can see, we can write like this, 1 by 3 tan of theta, this should be less than equal to 0.25. Clear? So from here we can see this theta should be less than equal to 0.75. Now this 0.75, we can see this tan theta, it should be less than equal to 3 by 4. Clear? And 3 by 4 value we have tan theta, it should be less than equal to tan 37. Clear? So from here we can see, whenever we have angle of inclination is 37 or less than that one. Clear? At that time we can say it will not skid. Clear? But as the angle increases above 37 degree, definitely this cylinder start skidding. Clear to you? So this is all about this question. Now dear student, we are going to discuss question number 7.32, and in this question it is given to you, read each statement and with reason tell me this is true or false. Clear? Now concentrate on a screen. In this question it is given part number A, during rolling the force of friction act in a same direction as the direction of motion of a center of mass of a body. Perfectly true. Clear? It is given during rolling. Clear? So I can say this statement is true. Clear? Because actually what is the work of this friction? Actually the purpose of a friction is to bring that body in a pure rolling condition. As the pure rolling condition is achieved, the friction force automatically becomes 0. It means we can say this statement is true. Clear? Now if I talk about statement number B. In statement number B it is given, the instantaneous speed of the point of contact during rolling is 0. Yes, definitely. Let's suppose if I am talking about, let's suppose here we have a body. Let's suppose this is any body, it may be ring and something else. Let's suppose if I am talking about this point of contact. So if I am saying in a pure rolling condition, the tangential velocity, let's suppose this is going in this direction omega. So I can say this V equal to R omega. This should be balanced here, clear? And how it will be balanced? Because let's suppose center of mass velocity, it increases up to R omega, clear? So at that time we can say this V equal to R omega and this V equal to R omega, clear? We can say at point of contact this V equal to R omega becomes, clear? So actually what I want to say, I just want to say whenever we are discussing about pure rolling condition, in pure rolling condition at point P, this velocity V, this should be equal to R omega. This is a condition of a pure rolling. Clear to you? Yes. Now, it means we can say this statement is true or false. This is true. Clear? Now, if I am talking about part number C, the instantaneous acceleration of a point of contact during rolling is 0. This statement is false. Why this statement is false? Let us try to understand. Yes. So I can say this statement is true, this statement true, and this one is false. Now listen carefully what I am saying to you. Let's suppose here we have this surface and let's suppose we have this body, clear? And let's suppose this body is in a pure rolling condition, clear? So in a pure rolling condition we can say this body does not have any translatory motion, clear? Translatory motion this body does not have, but actually this body is rotating, clear? Or actually this body is rolling, clear? So in a pure rolling condition we can see acceleration will always act at a point of contact that is towards center along radius, that is known as centripetal acceleration. So always keep in mind we can say in a pure rolling condition at a point of contact you will always find velocity V equal to R omega, or net velocity at the point of contact, that is 0. Yes or no? But what about acceleration? Acceleration, it may or may not be 0, but because we can say here this is a rolling, so whenever we have a circular motion, centripetal acceleration come into picture, clear? So we can say this statement is false. Okay. For perfect rolling motion, work done against friction is 0. Definitely true. Why? Because if we are talking about pure rolling condition, in pure rolling condition we can say value of friction is 0. Clear? So value of friction is 0, it means this is true. Clear? Last one. A wheel moving down a perfectly frictionless inclined plane undergoes slipping, not motion. This is also correct. Why? Because rolling is possible only due to friction. When friction is absent, definitely we can say that body just skid. You can see, let's suppose we have a rough surface, I have a ball, at the time the ball will move like this, clear? But let's suppose I have frictionless surface, at the time that ball will move directly like this, it only skid, clear? So directly we can say this statement is also true, clear? So this is all about this question. So student, we are going to discuss question number 7.33, clear? In this question it is given to you separation of a motion of a system of particles into motion of center of mass and motion about center of mass is given to you, clear? Actually we have to talk about motion of a system of particle with respect to ground, motion of a system of particle with respect to center of mass, and motion of center of mass with respect to ground, clear? So this is very simple concept, clear? So now related to this statement we have total 4 more statement A, B, C and D, and we have to show one by one that how can we reach to this expression, clear? So first of all I am going to discuss we can say part number A, clear? So concentrate. Now if I talk about number A, we have to show here this Pi, it should be equal to Pi dash plus Mi and V, clear? First of all let us try to understand. Let's suppose this is M, let's suppose this is a body having mass M, we can write like this. Let's suppose we have a body having mass M1, clear? Let's suppose we have another body having mass M2. Let's suppose this is another body having mass M3, clear? This is another body M4, and we can see, let's suppose this is body I am taking, this is ith body and mass of ith body is mi. Clear? So we are taking all bodies as a system. Clear? So I can say this is system of a particle. Clear? Now let's suppose we have center of mass of this system of particle at this position, and let's suppose velocity of center of mass, it is given by capital V. Clear? So now actually I am defining, or actually it is given also. So again I am writing, first I am writing Vi. Vi means what? This is velocity of ith particle with respect to ground. Clear? So if nothing is given, it means you have to take it into with respect to ground. Clear? So velocity of ith particle, velocity of ith particle with respect to ground. If nothing is given, we will take it with respect to ground. Clear? If I am writing like this, Vi dash. Clear? Vi dash, it means what? We can say this is velocity of ith particle, velocity of ith particle with respect to center of mass, with respect to center of mass. Clear? So this is value of Vi dash. Clear? And now I am taking, this is capital V. Capital V is what? I can say this is velocity of ith particle with respect to center of mass. Clear to everyone? So how can we write like this? Can we write like this? Vi dash. Vi dash means what? Velocity of ith particle with respect to center of mass. Clear? And we can say this is equal to velocity of ith particle with respect to ground minus velocity of center of mass with respect to ground. Clear? So can we write like this? Vi, this should be given by Vi dash plus capital V. Clear? Now if I multiply mass of ith particle both sides, we can write like this: Mi Vi, this should be equal to Mi Vi dash plus Mi and multiplied with capital V. Clear? Now you can say this is what? This is linear momentum, or we can say momentum of ith particle with respect to ground. So we can say this is Pi. Clear? Now this is what? This is momentum of ith particle with respect to center of mass, plus we can say this is this is momentum of a center of mass of ith particle. Yes. So now we can say, we can write like this: Pi, this should be equal to Pi dash plus Mi into capital V. Clear? So this is the first part that we have to derive in this expression. We have to show that Pi, this should be given by Pi dash plus Mi and multiplied with capital V. Clear? So now we have to also find, we have to prove using the definition of center of mass, summation of Pi dash, it should be equal to 0. Clear? So now you can say Pi dash, this Pi dash, it is given by Mi and Vi dash. Clear? Now if I take summation both sides, we can write like this: this is Pi dash, it should be equal to summation of Mi and we can say this is Vi dash. Clear? So we can also write it like this: summation of Mi, we can say this is Dri dash divided by dt. Clear? So from here you can write like this: summation of P, we can say I dash, it should be equal to, now I am taking this dt outside. Let's suppose we are writing this is 1 by dt, we can write like this: summation of Mi and this is Dri dash. Clear? Now if we talk about the product of mass and the distance from center of mass, with respect to center of mass we are taking, and this will always come out to be 0. Yes or no? Clear? So from here you can say summation of Pi dash means momentum with respect to center of mass, you always find this value is equal to 0. Clear? So this we have to prove. Clear? Sometimes student gets confusion. Let's suppose you are taking, this is axis, and let's suppose I am taking, this is position of center of mass. Clear? Now let's suppose we have a particle m1 mass, let's suppose it is having a distance r1. Clear? Now let's suppose we have another particle m2 and we can say this is r2. So with respect to center of mass, you always find m1 r1 plus m2 r2 plus dot dot dot, it should be equal to 0. Clear? And we can write this as summation of mr, it should be equal to 0. Clear to everyone? So in part number A, now we have to prove first pi equal to pi dash plus miv, number 1, and second one we have to prove this summation of pi dash, it should be equal to 0. So clear? Now student, we are going to discuss part number B. In part number B, we have to prove kinetic energy K, it should be equal to kinetic energy K dash plus half of mv square. So it should be clear in your mind what is K. K is kinetic energy of ith particle with respect to ground. K dash is what? Kinetic energy of ith particle with respect to center of mass. Clear? And now we can say this is a half of mv square, it denotes translation kinetic energy of with respect to, or we can say it is a translation kinetic energy of a system of particles. Clear? So now we have to prove this expression. Clear? So now recently in part number A, we have already proved this expression pi equal to pi dash plus m into capital V. Clear? Now can we write it like this, mi, and we can say mi, this is vi equal to, I can say mi vi dash plus capital M V. Clear? Now what I am doing, I can write like this, summation of mi vi. Clear? Summation of mi vi. Clear? It should be equal to summation of mi vi dash plus summation of mi into multiplied with v. We can write this capital M as a mass of m1 plus m2 plus m3 plus m4 and so on. Clear? So now let's suppose I am saying this is equation number 1. Clear? Now what I am doing, I am taking a dot product with the same equation. Clear? It means what I am doing, I am taking dot product with same equation. So how can I write? I am writing this side, summation of mi vi, this should be equal to summation of mi vi dash plus we can say it should be summation of mi, and we can say this is capital V. Now I am taking dot product with same equation, so we can say summation of mi vi dot summation of mi vi. Clear? It should be equal to, now I can take summation mi common first, this is vi dash plus capital V. Now I am taking with same expression, dot product with same expression, so summation of mi, we can say vi dash plus capital V. Clear? So now you can say whenever we are doing dot product, we can say it is given by summation of mi whole square, and I can say this is vi whole square. Clear to you? From here you can say we can write like this, summation of mi, this is whole square. Now what I am doing, I am taking dot product, so vi dash dot vi dash, this is equal to vi square. Clear? Plus we can write like this, vi dash multiplied with capital V plus v dot, I can say this is vi dash plus I can say this is v square. Clear? Now what I am doing, I am writing like this, this summation of mi means m1 plus m2 plus m3 plus mn, so we can say this is equal to capital M, so I can say this is capital M square, this is vi square, it should be equal to, we can say this is capital M square. Clear? Now what about vi square? Vi square, so we can say vi square, so I am writing just like this, vi square plus I can say capital V square plus we can say vi dash capital V plus v dot vi dash. Clear? Now what I am doing, actually I am multiplying with m square both side like this, m square, this is vi square plus I can say m square v square plus m square. Now what I am writing, listen very carefully, actually both are same, yes, v dot vi, so from here you can say this is 2 times, so v dot vi. Clear to everyone? Yes or no? So from here you can say, actually you can write whenever we are doing summation. Clear? So can we write it like this, summation of mi, yes, if you are multiplying you can say this is equal to m square Vi square, this should be equal to m square Vi square plus capital M square V square plus. Now what I am saying to you, now can we write like this? This is equal to 2 times, or we can say summation of mi square v dot vi dash. Clear? Now you can say if I take this common summation of mi, if I take summation of mi, clear, summation of mi into v or vi dash, this always come out to be 0, yes or no? Because in the last expression we have already seen that summation of pi dash, it should be equal to 0, yes or no? We can say this should be equal to summation of mi, and we can say vi dash, it should be equal to 0. So from here you can say we can write like this, m square vi dash square, this should be equal to m square vi square plus capital M square v square plus 2. Clear? Now I am taking this summation mi first outside, this is capital M, and I can take this as 1. So from here we can say this is summation of mi dot, we can say vi dash. Clear? So I can say this is equal to summation of pi dash, yes or no? And this summation of pi dash, it should be equal to 0. So I can, this term is getting out to be 0. Clear? Now what I am doing, I am multiplying half with both sides. Clear? I am multiplying with half both sides. So this is equal to half of m square vi dash vi square 1 by 2 m square vi square plus 1 by 2 m square v square. Clear? Now we can say what is this? We can say this is K, kinetic energy. This is equal to, I can say this is dash. Clear? This is dash. So we can say, just a minute, yes, this is dash. Okay, this is dash. Clear? Vi dash, correct. Clear? So now we can say, we can write like this, this is equal to K, this is equal to K dash, and this is equal to half of mv square. Clear? So final expression that I am writing, K equal to K dash plus half of m, and this is v square. Clear? Now from here you can see that this is an expression for what? This is an expression for kinetic energy of system of particle with respect to ground. This should be equal to kinetic energy of system of particle with respect to center of mass. Clear? Or you can see, because we are talking about ith, we are talking about n number of particles. Clear? And now we can say this is translation kinetic energy of a system of particle. Clear? So this is an expression that we want to derive. Clear to everyone? So now we can say this is all about this part number B. Clear to everyone? So now student, we are going to discuss part number C of this question. Clear? And in this part it is we have to prove that L is equal to L dash plus R cross MB. Clear? So before that, actually I am defining here 3 terms. Clear? So these 3 terms are, number 1 Ri. Ri, we can say this is position of a ith particle, position of ith particle with respect to origin. Clear? You can say with respect to origin, you can say with respect to ground. Clear? Now we can say Ri dash, this is what we can say, this is position of ith particle, position of ith particle with respect to, position of ith particle with respect to, we can say center of mass. Clear? And now I am defining one more term, that is capital R. This is position of center of mass with respect to origin. Clear to everyone? So how can we write value of Ri dash? Clear? Ri dash, this is what? Position of a particle with respect to center of mass. So we can write it like this. This should be equal to position of a ith particle with respect to origin minus position of a center of mass with respect to origin. Clear? So now I can say Ri, this will be given by Ri dash, and we can say this is plus R. Clear? This is plus capital R. Clear to everyone? So let's suppose I am saying this is equation number 1. Now you have already seen in part number A that Pi, clear, pi is given by, we can say this is pi dash plus capital, we can say this is equal to capital mv. Yes or no? Yes or no? So we can say this expression we know this is capital mv, capital mv. Clear? So let's suppose I am saying this is equation number 2. Now dear student, what I am doing? I am doing, actually my objective is to calculate angular momentum, and we know angular momentum L, this is given by r cross p, r cross p. So now you can see for r cross p, what I am doing? I am doing with ri, this is ri, I am doing cross product with ri with this equation. Clear? So what I am saying to you, okay, let us try to understand. Concentrate here. First I am doing cross product ri with pi, and actually I am doing this cross product both side. Clear? So we can see, we can write like this, ri cross, this is pi dash plus, we can say capital M B. Clear? Now you can see, we can also write like this, summation of ri cross pi, this should be equal to summation of ri cross pi dash plus capital M B. Clear? Now we can place value of ri. Value of ri, we have ri dash plus capital R. Clear? So now we can see this is ri cross pi. Clear? It should be equal to, now we can see this is ri dash. Clear? This is equal to ri dash plus capital R plus capital R cross, we can say pi dash plus capital M B. Clear? Now you can say ri cross p, we can say this is equal to li. Clear? Or simply you can say this is equal to L. Clear? So we can say this is li equal to, clear? Now we can say if you doing cross product, so cross product we can say this is ri dash cross pi dash. Clear? Clear? Plus ri dash cross capital M V. Clear? Capital M V plus, we can say r cross, this is pi dash plus, we can say r cross capital M V. Yes or no? Clear? So now what I am doing, what I am doing, can I take, or okay, what I am doing, can I take summation both side? Yes or no? Because this is just a cross product. Clear? Whatever we have done, this is just a cross product, and actually you can say this is also mi, because this time we are not doing, this is summation of mi, so directly you can say this one. Clear? So now listen very carefully. So we can write like this, li, this should be equal to ri dash cross pi dash, we can say this is li dash plus, now we can say summation of, we can say ri dash cross, we can say this is mi, so mi into v. Clear? Plus we can say summation of r cross, this is pi dash plus, we can say r, we can say cross summation of mi multiplied with v. Clear? So from here you can see, we can write like this, angular momentum of ith, angular momentum of ith particle, this should be equal to I dash plus, now you can see, we can write like this, ri dash cross summation of mi into, we can say this is v. Clear? Plus we can say, we can write r cross summation of pi dash plus r cross capital mv. Now listen carefully. In expression number A, you have already seen this value is equal to 0, and summation of mi into v. So with respect to center of mass, the net summation of momentum, this is also 0. So directly you can say li, this is given by li dash plus, we can say r cross mv. Clear to everyone? R cross mv. Clear? So now you can say, what is our objective in this question? Our objective is to show this expression, so we have already shown here. Clear? So now we can say this is angular momentum of ith particle. Clear? With respect to origin, this is angular momentum of ith particle, or we can say, you can directly say, whenever we are doing summation, this is angular momentum of a system of particle with respect to origin, angular momentum of system of particle with respect to center of mass. angular moment. This is what we can say, this is r cross simple mv. Clear? So we can say this is all about part number C. Now we are going to discuss part number D of this question. Clear? In this question we have to prove dl dash over dt, this should be equal to summation of ri dash plus cross dp by dt. Clear? dp dash by dt. So in part number C we have already proved that L is equal to, we can say L, this is equal to L dash plus R cross MV. We have already proved it. Clear? So how can we write? Actually in this question our objective is to prove this one. Clear? So from here you can say, we can write L dash. L dash is equal to what? We can say Ri dash cross Pi dash. Yes or no? And we can say this is equal to a summation also. Clear? So from here how can we write it? Clear? So L dash, this is equal to summation of Ri dash cross Pi dash. Clear? Now what I am doing? I am doing dl dash by dt. Clear? We can write like this, dl dash divided by dt, and this should be equal to d by dt, and we can say summation of Ri dash cross, we can say this is Pi dash. Clear to you? Now can we do this dot product? Yes. So we can write like this, dl dash by dt, dl dash by dt, and this should be equal to, we can say summation of Ri dash cross, we can say this is d by dt and Pi dash. Clear? Plus. Actually I am applying here u dot v formula. So summation of Ri dash cross d by dt Pi dash plus, we can see this is equal to, we can say Pi dash summation, we can see from here you can say, first I am differentiating Pi dash with respect to time. Now I am differentiating this summation r with respect to time t. Clear? So I can write like this, it is cross d by dt, and we can say this is Ri dash. Clear? So now from here you can see dl dash over dt, dl dash over dt, and this is given by summation of Ri dash cross. Clear? And we can see this is d by dt Pi. Clear? Dash plus. Now listen carefully. Actually we can write it like this, this is Pi dash cross, and we can see Pi dash cross, and this is d by dt, and we can say this is Ri dash. Now listen carefully. Can we write like this, this is equal to capital M. Clear? And I can say this is Vi, we can send it inside. Yes or no? Can we write like this? Yes or no? Or you can say, actually if you are writing summation, you can say this is summation Ri dash. Clear? So from here you can say summation of Ri dash cross d by dt, this is Pi dash. Clear? Plus. Now we can say this Pi dash cross summation of, we can say this is equal to summation of Ri. Clear? So d by dt summation of Ri dash. Yes, this summation of Ri dash means we can say position of a particle, ith particle with respect to center of mass, and we are taking summation. So this summation, or you can say you can multiply it with mass also. Yes or no? Yes or no? Yes, we can do it. Clear? Actually you can also write it like this. If I am saying this is Pi dash. Clear? And if you are writing here, you can also write it like this. You know that linear momentum is equal to mass into velocity. Clear? So I am saying this is velocity Vi dash cross, we can say summation of Mi dash, and this is Ri dash. Yes or no? Summation of Mi dash and Ri dash, definitely now you know this is with respect to center of mass, and this is 0. So from here you can see, we can write like this, dl dash by dt. Clear? This should be equal to, now this is summation of Ri dash, summation of Ri dash cross, clear, d by dt Pi dash, d by dt Pi dash. Now you can see from Newton's second law of motion, rate of change of linear momentum, it is actually external force acting. Yes, so we can see dl dash over dt, this should be equal to summation of Ri dash cross, we can say d by dt, this one. So this is Fi dash, you can say. So R cross F equal to, we can say this is net external torque acting, clear. So one expression that is required to derive this is expression number 1, and we can also write it like this. This is dl dash over dt, this should be equal to tau external, clear. So I can say this tau external is what? This is torque acting on a system of particle, clear. Torque acting on a system of particle with respect to center of mass, yes or no? So I can say this is the required, clear. So you number second expression this one, number first we have this one, so we have derived all the expression, clear to you. So dear student, this is all about this question, clear. So dear student, this is all about all the NCERT and exercise solutions of chapter number 7, system of particle and rotational motion, clear. So hope you enjoyed this discussion, and definitely if you solve all these questions, your theory will be also built up, clear. So this is all about this discussion. Thank you.